5.66 times 10 to the 23rd atoms. That is your given quantity, so that's what you're going to write first. You've got how many atoms, your unit, and what element you're referring to. So anytime you have atoms as your given, you know the only thing you know about an atom is in 1 mole of it, how many atoms there are. So your first conversion factor has to have 1 mole on top and atoms on bottom. And since you're going to moles, that is where you end. You're going to type that into your calculator, and you're going to end up with 0.940 moles of xenon. Now for the next one, it says how many moles of silver nitrate. I'm going to scroll up. Remember, you can pause since this is a video if I am moving too quickly. So how many moles of silver nitrate? That's what I'm going to. I want to know how many moles. And this is my given quantity, and it's in formula units. So remember, formula units is the subunit for an ionic compound. So we're starting with 2.888 times 10 to the 15th formula units. Oh, I forgot to write of iron sulfate. I know in 1 mole of iron, I said sulfate, nitrate, sorry guys. Nitrate, I'm trying to go quick. Haste makes waste. NO3, and that means that I have 6.022 times 10 to the 23rd formula units of silver nitrate. And that is going to give me formula units cross off, and I'm in moles of silver nitrate. So I take 2.888 EE to the 15th divided by Avogadro's number. Oh, trying to see if I have my other calculator. Go ahead and type that into your calculators. You should end up with a final answer of 4.796 times 10 to the negative 9th moles of silver nitrate. All right, go ahead and pause the video to try setup number 3. I'm just going to move right into it. All right, we're starting with 2.7 times 10 to the 17th termites on Earth. They want to know how many moles of termites. So 6.022 times 10 to the 23rd termites is equal to 1 mole of termites. So I'm going to take 2.7 times 10 to the 17th divided by 6.022 times 10 to the 23rd, and I'm going to get an answer of 4.5 times 10 to the negative 7th moles of termites. Now remember, when you are dividing by an exponent, a way to double check your answers, you were taking this divided by that. You could take 17 minus 23, and that should be what your exponent actually is, or at least close to. All right, circle or box your final answer. All right, go ahead and set up the next problem. Oh, come on, no. This could be an undo button, sorry. There we go. All right, so we're going to start by writing out our given quantity, which for this problem is referring to how many lithium ions we have, and you want to convert to moles. So our given quantity is 5.66. Sometimes decimals are hard to see, so try to overemphasize them. Times 10 to the 25th, and lithium ions. That positive sign literally means ions. All right, I know in 1 mole of anything, I have 6.022 times 10 to the 23rd lithium ions. All right, so my lithium ions cross off, and I'm in moles of lithium. If I go 5.66 times 10 to the 25th, divided by 6.022 times 10, so we should get 25 minus 23 means 2 decimal places approximately, so I have a double check here. My answer key was wrong on the first one here. 0.94 moles of lithium ions is my final answer. Also, what would be true would be 9.40 times 10 to the negative first moles of lithium ions. It's always best to keep practicing your scientific notation. Soon it will be required. All right, now we get down to the more challenging one, mostly just because it had, well, there's 2 reasons. The instructions were kind of confusing, and then secondly, I would say because you had to do more than one step in some of them. So remember when I said, I'll just write some notes here, if they're wanting to get down to oxygen atoms within this many molecules of carbon dioxide. So if you were to have 1 molecule of carbon dioxide, you'd have 1 atom and 2 atoms. So 1 atom of carbon, 2 atoms of oxygen. But if you have this many molecules, it's going to be a lot different. So there is more than one way to do this. I'm just going to do it the more consistent with our current process. And that's definitely by starting with our given. So 3.161 times 10 to the 21st. I would spell out molecules because it's easy to get it confused with moles when you abbreviate, obviously, of carbon dioxide. So we got a lot of them. And I know if I have 1 mole of CO2, I'm going to have 6.022, my decimals there, it's hard to see, times 10 to the 23rd molecules of carbon dioxide. Notice why naming well is important at this point. Okay, I'm not where I need to be. I'm into moles of carbon dioxide. But if I know if I have 1 mole of carbon dioxide, I also know I have 1 mole of carbon and 2 moles of oxygen. So 2 moles of oxygen. So moles of carbon dioxide cross off, and I'm into moles of oxygen here, which I should probably take the 2 off. I'm just talking about oxygen. Sorry, that was redundant. Okay, because that 2 is why I put this guy here. So we're going to just take 3.161 times 10 to the 21st divided by Avogadro's number and take it times 2. Now let's think about it conceptually. Down to this point, we're getting 2 moles of carbon dioxide. And I know if I have 1 of these, I have 1 and 2. So if I'm trying to get to oxygen, I have to take it times 2, which is what I am doing. All right, so then my final answer here comes out to be with 4 sig figs, 1.050 times 10 to the negative second moles of oxygen atoms. Okay, I wanted to get to moles of atoms because it is in the instructions. And they're just saying whether you're talking about atoms or ions, get down to how many moles of them you have. So I have this many moles of oxygen atoms, which written in standard notation, remember if it is to the negative 2, it started as 0.00 because I went 1, 2, oops, sorry, 1. This thing's not as easy to write on as the board is. 1050, because I went 1, 2 places over. And that was moles of oxygen atoms, is what your calculator probably said. But again, I encourage scientific notation anytime it is not something just in the tens place. All right, now the next one. We do the same process, but I'm going to zoom out so you can see it too. But now we're going to talk about carbon atoms. So the only thing that's going to change is actually this step right here, because instead of 2 moles of oxygen, we only have 1 mole of carbon. So you're going to start with 3.161 times 10 to the 21st molecules of CO2. And I know in 1 mole of CO2, I have 6.022 times 10 to the 23rd. Molecules of CO2. All right, so I'm out of molecules, those tiny little guys, and I'm into moles, the SI base unit for how much we got. Now I can get from how much of this to how much of carbon atoms. So how many moles of carbon atoms is what the question asked. So I know if I have 1 mole of carbon dioxide, I then also, because there's no subscript behind the carbon, know that I have 1 mole of carbon. This just changed my units, because now I'm in moles of carbon for my unit. So this divided by this, and I was only given 4 sig figs to work with. So it comes out to be 5.250 times 10 to the negative third moles of oxygen atoms. I need to change my calc batteries. I finally gave up. That's why my last examples were not quite spot on, is my batteries were dying. Right? Oh, no, that's not what I want to do. Darn it. Okay, this is what I wanted. All right, now I am on letter C of the final question for your homework here. All right, so as always, I'm going to start by writing out my given quantities. 2.222 times 10 to the 24th molecules of nitrogen monoxide. I'm in molecules. The only thing I know about a molecule is that there is 6.022 times 10 to the 23rd of them. In, what am I doing? Of molecules of nitrogen monoxide in 1 mole of nitrogen monoxide. So molecules, apparently I literally started crossing that off, cross off, and I'm in moles of nitrogen monoxide, but I want to get to moles of oxygen atoms. There's only 1 oxygen atom present. So in 1 mole of nitrogen monoxide, I have 1 mole of oxygen atoms. So mathematically, 2.222 times 10 to the 24th divided by Avogadro's number, and I am going to result with 4 sig figs to, oh boy, I can't really read my handwriting. I think it says 3.690 moles of oxygen atoms. All right, type it into your calculator. You just take this, divided by that, multiplying by 1 and dividing by 1 isn't going to change your answer. All right, fun little bit. If I were to some reason require you to, at some point, to put a number into scientific notation that is already in the standard form here, it would be times 10 to what power? How many times would you have to move the decimal? You would have to move it 0 times. So mathematically, 10 to the 0 is actually equal to 1. because you're taking 10 times nothing, so it's just 10. So this is how, if for some reason I wanted to be real fun sometimes and require all of them in scientific notation, you could do it. All right, D, let's start with our given quantity, 5.324 times 10 to the 16th, abbreviate of potassium. Oh, I wrote nitrate. I had nitrate in my head there. Potassium nitrite. All right, so I know because that's a metal and that's a polyatomic that this is definitely a formula unit, which is what they told us. And a formula unit breaks down into ions. So we want to know how many moles of potassium ions are present. There's 1 part per molecule, but how many per mole? So we're going to say in 1 mole of potassium nitrate, I have Avogadro's number. Formula units of my N, potassium nitrite. So formula units cross off. Now I have 1 mole of potassium nitrate on top, and I want to get to moles of potassium ions alone. So if I have 1 mole of potassium nitrite, I am going to have 1 mole of potassium ions. So moles of potassium nitrate cross off, and I am at moles of potassium ions, which is where I wanted to be. So mathematically, you just take the given quantity, 5 points. Don't do that. How do I get out of this? Okay. 5.324 times 10 to the 16th divided by 6.022 times 10 to the 23rd. And again, if you are good at dimensional analysis, you would see that this is, or it's called power of 10 rule actually. This exponent minus this exponent should give you the approximate exponent of your result here. So my result, I found D to be 8.841 times 10 to the negative 8th. All right, and my unit is moles of potassium ions. There be. All right, now we have E, F, and G. Oh my goodness, we got a lot left here. Okay. Sorry, I'm breathing into my microphone. All right, start with our given quantity. This time, we're going from formula units down to chloride ions. So 1.000 times 10 to the 14th formula units of magnesium chloride. I hate those lowercase. I need to go to chloride ions, so we got to get to the mole bridge first to get there. So we know if we have 1 mole of magnesium chloride, I have 6.022 times 10 to the 23rd formula units of magnesium chloride. So formula units cross off in moles of magnesium chloride in 1 mole of magnesium chloride. I actually have, because there's a 2 there, right here, I actually have 2 moles of chloride ions. My unit is moles of chloride ions like I wanted to, so my answer is going to be, I'm on E, I gotta scroll here, is going to be 3.321 times 10 to the negative 10th, and that unit is moles of chloride ions. That negative sign is what tells me that's a chloride ion. All right, F, I'm going to try and move quicker. Remember, you can pause and try to set these problems up yourself. I encourage you to do that. It's that independent thinking is that's going to make this actually stick for you. Formula units of calcium. There we go. There's some nitrate. I hate that it's all caps. All right, how many nitrogens? All right, so if I have 1 mole of calcium nitrate, I have 6.022 times 10 to the 23rd. What? 6.022 times 10 to the 23rd formula units, because it is an ionic compound, because calcium is a metal and nitrate is a polyatomic. So formula units cross off. I'm in moles of calcium nitrate, which we call the mole bridge. So 1 mole of calcium nitrate is equal to how many moles of nitrogen atoms? Okay, the dicey part here is you have to realize that this parenthesis out here means I have 2 nitrates. So I have 2 nitrogens and 6 oxygens. So 2 moles of nitrogen atoms. And again, it's called atoms this time because they're not charged. This is covalent, not ionic. So mathematically, 2.000, those are there for sig figs, times 10 to the 14th, divided by 6.022 times 10 to the 23rd. Again, use your base rule to keep yourself straight. If you get some really bizarre off-the-wall number away from 14 minus 23, I would say it's going to be based on where you move the decimal and what these base numbers are. But if you take 14 minus 23 and you're more than 1 exponent off, above or below, something is not right. That's the other perk to working in scientific notation only. All right, so my final answer F is 6.642 times 10 to the negative 10th, because 14 minus 23 would have given me a negative 11, and we're approximately there. So my unit is moles of nitrogen atoms. All right. Maybe someday I'll find a way to make these more interesting for you guys. Today is not that day. Minus all my random breathing in the microphone. All right. Yeah, this means exponent. If you ever see this piled up, ask me, but when I copy and paste over from your forms, I just put it in there, and if I don't remember to go back and add it, this is what we get. Come on. 4 million units of magnesium, lowercase, PO4. So this is magnesium phosphate. And they want to know how many oxygen atoms. And the reason they're saying oxygen atoms, even though this is ionic, that would make a really fun test question, is because even though this is an ion and this one's bonded as an ion, within this, that phosphorus and the oxygen bonded covalently, because phosphorus is a nonmetal, oxygen is a nonmetal. So we break down just the oxygen. That is an atom. But if we had said phosphate, it would have been phosphate ions, or magnesium, it would have been ions. So I know if I have 1 mole of magnesium phosphate, I have 6.022 times 10 to the 23rd formula units of, it's still an ionic compound overall, of magnesium phosphate. So I'm out of formula units, and I know if I have 1 mole of magnesium phosphate, I have, there's 4 oxygens times 2, so 8 oxygen. Let's go 8 moles of oxygen is how I should say that, 8 moles of oxygen atoms. Okay, so moles of magnesium phosphate cross out, and I'm in moles of oxygen atoms. So you take 4.999 times 10 to the 25th divided by 6.022 times 10 to the 23rd, 25 minus 23. 3 is going to give me to the exponent of 2, which should make sense because my answer is 662.9 moles of oxygen atoms. I'm going to write this in scientific notation for you. Again, I encourage you to keep practicing, especially if it's homework. 6.629. Remember, your base number needs to have 4 sig figs for this one. Times 10, and I move it 1, 2 to the second. Moles of oxygen atoms. Always abbreviate for formulas and names. Do not put the full, don't spell it oxygen, don't spell it magnesium phosphate. Write your formulas, even if I spelled it out in the given. Oh, I thought we were done. Okay, how many more? Oh, maybe we are done. Maybe I accidentally just added a bunch of pages. We are done. I just added a bunch of pages. Okay. Well, in summary, let's well, scratch that. The bell has rung.